So welcome to Curating OpenTofu Modules and Patterns, a talk where we hope you will take away some best practices for curating and using modules internally, wherever you're from. So I'm Douglas Flagg. I'm a Director of Cloud Engineering at Fidelity, and I have the pleasure of speaking alongside Carroll, who's also a Cloud Engineer. So both myself and Connor work on the IaC Platform team at Fidelity, and our team's goal is to make it easy for other dev teams within Fidelity to use IaC. Specifically, that means OpenTofu. And a big part of using Tofu is knowing when and where to find Tofu modules internally instead of rewriting the same functionality again and again. So let's give a little bit of background on Fidelity. We are a fintech company. We have $15 trillion in client assets under administration. That's Fidelity, not me. And Fidelity employs 18,000 technologists worldwide across the US, Ireland, and India. And we have more than a dozen different business units. So let's preview what we're going to talk about today. So we'll begin by reviewing what we previously discussed with how Fidelity uses OpenTofu, and that was last year. We'll get into that in a minute. Next, we'll level set by investigating why we use Tofu modules and how they are best used. Then we'll discuss our Fidelity's common modules. Then we'll move on to the catalog where users can find and discover all of the Tofu modules that they might want to use. Building on top of the common modules, pattern modules will implement those full end-to-end solutions. And we'll return to measure how our modules work effectively. Again, some common standard that we want all modules to follow. We'll bring things back full circle and talk about how we manage the full lifecycle of modules internally. And finally, shifting left, we're going to demonstrate how Bento now works in the IDE and how you developers can discover shared modules directly from within VS Code. All right, so let's give some context on the scale of OpenTofu usage at Fidelity. So we have about 75,000 state files that manage about 5 million cloud resources, and that represents about 2,500 applications using those state files. And so when I originally wrote this, when we originally wrote this, 99% Tofu usage was still correct. This isn't correct anymore. And as of last week, we only allow the Tofu CLI to use the state backend. So this is effectively 100%. So we mentioned earlier, we have over a dozen business units that make up Fidelity, and each has historically had its own way of doing things with respect to IaC. Among those BUs, there's many hundreds of development teams that implement those individual ways of doing IaC, so we want some standard way to do things. So the main challenge we seek to solve through standardization is how do we ensure that they are not all solving the same problem again and again, repeatedly in isolation. So next, how can we ensure that those users can find those modules that are being shared? And then finally, we want to determine whether one module is better than another if each is doing something similar. How do we measure them and say this one is better or worse than the other one? And these questions are what the balance of this session is going to focus on. Okay, so let's add a little bit more context on what we talked about last year in Salt Lake City at OpenTofu Day. We discussed the Bento IaC Platform. Let's quickly review what that is. So in the past, Fidelity had many IaC tools. We now are focused on growing OpenTofu as our IaC tool of choice. And Bento is just the name of the platform. It's our internal name for that platform that we use to enable IaC at Fidelity. Specifically, that's going to mean using OpenTofu internally. And our presentation last year focused on the entire Bento IaC platform. And this year, we're just going to focus on one big component of that. And that's how we manage module development. And that's the part highlighted in red there. Just to show we're not talking about the same thing we did last year. So let's quickly level set on what modules are. So any Tofu source you write is technically a module. That first level module where you're running Tofu init, plan, and apply is known as the root module. Root modules often add dependencies on other modules through module blocks. These will be called child modules to that root. It's best to use child modules for handling any kind of repeated or complex tasks that you judge are worth abstracting away into its own separate place. Some practices you probably want to avoid when developing shared or child modules. You don't want to deeply nest your modules. You don't want a Matryoshka doll of modules where you have modules within modules, because having many layers of modules within their own child modules makes debugging issues and module version upgrades far more complex. You don't want to overuse by adding every little bit of logic into small modules, because you'll begin to wonder, what is this module doing? And finally, there's no point in really thinly wrapping a single resource in a module without any additional changes, because it doesn't add any benefit. You're just adding an additional layer of complexity for no benefit. We find that generally the most useful modules are those developed to handle specific challenges that many teams are facing. Often we see this refactoring opportunity manifest in a series of similar resource or data blocks that appear repeatedly throughout root modules. So you see this if you have a lot of different teams using Tofu or Terraform, you'll see the same patterns appear again and again. That's when you know you have something that might be able to be reused. So now that we have some rough best practices for how you can use modules, let's look at how we use modules internally. So these are what we're going to call our common modules, and these normally implement one small function centered around a single common cloud resource. But at the same time, we still want to avoid thinly wrapping these resources with a module. What these are going to do is actually implement some security controls that we have in place. So this module layer is used to codify our internal cloud security guardrails and our best practices that we require in our cloud environments at Fidelity. These controls might be, for example, that all data at rest must be encrypted. So if we had an EBS volume, this module ensures that all of the disks that are there are encrypted. And it prevents that module user from being able to create any resources that violate the controls. So this means that the individual module user doesn't need to understand all the details of the security controls by heart and can simply rely on that trusted module to handle the heavy lifting there. Now, each module is developed through an inter-source collaboration where anyone internally, even those not on that maintaining team, can contribute back and see the code. Ultimately, though, it's going to be the team that contributes the module that needs to keep it up to date and is responsible for providing some support for users if there are problems. So because we have a deep catalog of modules, we do see different patterns begin to coalesce around which are the most common and which are the most useful modules, because we can see them being used again and again. So we now have plenty of helpful modules that solve those security guardrails. So now we can focus on how do we help users find those common modules we want them to use. The module catalog is where that's going to be done. And that's where users can search for other different modules. It's a centralized portal where developers can easily discover and filter results for shared Tofu modules. Now, these modules that are more prominent are usually the ones that are more prominent in the catalog by default are the more mature modules. We'll get into what that means in a second. And this is so that users don't need to know how to search through the catalog for what they need. Just the ones that are best are usually most visible. It's built in a custom component we maintain in our internal Backstage developer portal. And each card in the module represents a single module. And you can see 3 of those cards actually right there. 2 for AWS and 1 for Azure. That's the blue one. The metrics presented on each card aim to show the user if this is best for them. So they need to be able to interpret some of the details. So at the top of the module card, we see the name and its maturity tag. And we also see a small description of the module. Below that, you have a snippet showing exactly how to use the module and an architecture diagram showing all the resources that the module uses. Now, these are all mocked up ones. We have real ones, but we can't actually share them right now. Below that, you can see any kind of activity or usage. You can see how the latest release is or the days since the last release, and this might help you infer whether this module is actually actively maintained. And then you can see which applications, these are the individual states using it, or which larger organizations are actually adopting and using these modules. So that can tell you, hey, a lot of people are actually using this, maybe I should use it too. We also have some tags, and then below that a link to wherever it lives in its GitHub repo, plus the team that actually maintains it, and a link to that team there. Any team or platform team from across Fidelity can contribute modules to the catalog and have them presented if they meet some basic requirements, which we will get into in a second. Let me just return to talk about our pattern module. So while our common modules solve simple problems, most teams need to combine many common modules together to create the resources necessary for their apps. The pattern modules are built to address the most common compositions of those common modules and package those into a single solution. The pattern modules also appear in their own pattern module catalog, and you can see one of those examples right there of a card for a pattern module. That's in Backstage also. These are patterns which implement our full architecture patterns, and they're far more opinionated. This is to limit the variable input to these, since these are doing a lot more, but a little bit less flexible. They can be used standalone or in conjunction with other modules. And these are nearly entirely built on those simpler common modules. So these will have 8 or 10 or 12 different modules within them. And I know we talked about nesting them. We're going to get into why. They let teams get started really quickly with really complex end-to-end solutions. Onboarding is straightforward because they're all very similar. But we still want to remain mindful of nesting any additional layers more deeply, as at this point, these modules, when you're using them, have grandchildren. We feel that the second layer of complexity is tolerable, given the ease of use it offers to end users, because it's deploying a full pattern out there. So this should be something that works end to end, whereas the smaller ones do not. They just solve one specific thing. Any additional layers of complexity would require a lot more benefit, because the additional complexity would be far more. So now that we have plenty of modules and a catalog to store them in, how do we measure them against each other and determine where they should go in the catalog and how they should be categorized? So the module maturity standard provides that answer by helping us compare modules against a pre-established checklist. Now, this has the benefit of encouraging teams to build modules in a standard way so they all feel relatively similar to use. Standardization requirements become more strict as we move up this pyramid, and they require more mature modules to be more similar. The maturity standard is created with the input of teams from across Fidelity, so it's not a top-down mandate. And the objective of the standard is the maturity tag that goes on each module, and it provides users at a glance an understanding of how much should I trust this module. And the sandbox layer, so let's dig into it. That's at the bottom there. It's purposely a low bar to entry and offers almost no guarantees except that it's syntactically a TF module. We generally discourage relying on those for anything that's critical. Incubating adds many more requirements on top of that and is considered good for general use. It's going to add requirements for testing, support, and operations, and release documentation requirements. Now that we build on top of Sandbox and incubating, the required level is going to add existing production usage. So this is going to check to see if resources from this module are actually being deployed into production environments. It also adds additional requirements on usage that many different business units need to be actively using this. These are considered battle tested and ready for all production use. And where possible, this is the actual grading of all this. And I know I've gone a bit over, so sorry, Connor. You go ahead now.
Thanks, Doug. All right. We did. Okay, we did move to the next slide. So now that we've got modules and patterns, we've hammered those down. We know what they are. And we've also told you guys about our module standards. We've got a few problems left to solve. So we need to solve the module lifecycle. So how can we ensure that users of our modules and patterns aren't using old versions or deprecated versions? And then we also want to assist new module developers in creating their first modules. So we've already got plans to restrict deprecated TF CLIs. As Doug stated earlier, we're fully on OpenTofu now, which is a part of that. So we plan to extend this capability towards our modules and providers to make sure that we're not having users with incompatible providers and modules. And then again, for our new modules, for assisting those authors, we have codified standard build and release processes so they can focus on the functionality of their modules instead of their release process. All right, cool. So this is a demo video, so I'll just have this open. And I'm sorry it's light mode. I know it's a sin, but but basically, as you can see, we've got a VS Code window. You're probably like, well, we can't see anything, but it'll zoom in, so don't worry about that. It's just a blank s3.tf file. This is a part of our kind of onboarding process for new IaC users within the company. It's the first challenge we'll give you, which is deploying an S3 bucket to an AWS account for the first time. As you can see on the left-hand side, there's a few options there. And that's part of our Bento VS Code extension, which is something we've been working on to enhance the developer experience surrounding OpenTofu and IaC as a whole. So let's go ahead and get started. Oh, the video. Oh, it's playing. Okay, cool. All right. So you can see we're opening up the modules tab. So this kind of brings the Backstage component straight into the IDE. It sorts modules by provider. We've got a few examples here. So we'll open up one of the modules. We see all the relevant data about the module. So we can see usage, business units, last release, stuff that I would want to know when I'm using modules. And it helps me decide which ones I want to throw into my TF files. So, and again, the maturity is also one of the more important things. It's sorted by maturity by default. So, but to the right of the module title there, the AWS API Gateway, we could see a few little buttons. We can add it to the Copilot context, which is something I'll show you guys a little bit later. Insert the module straight into our TF configuration and preview the module. So I'll just show you the insert module button that basically just goes to the GitHub repository and pulls the examples straight from the GitHub repo from the latest release, which just removes a quick step that I'm sure everybody kind of gets annoyed with, which is alt-tabbing between GitHub and VS Code over and over, or just a few times. It just removes the whole thing, which I find really useful, and a few users we have already do too. So we'll go ahead and remove that, and we're gonna close out all the stuff related to the modules, and we'll showcase the providers tab, which kind of replicates a few of the features of the modules tab. So we've got, again, sorted by provider. We'll pull up one of the AWS patterns, which is just modules of modules. You can see we've got similar stats on the patterns, which like latest release, we could see the forks, contributors, all that fun stuff, but you see a little architecture diagram button, which we can view the architecture diagram. But we can also click in and see all the modules that are present in the module of multiple modules, basically just nested modules, which means we can look further into a pattern. So we'll close this, and I'll get to show you the most fun part of the extension is that we've kind of integrated with Copilot to essentially apply our guardrails by contextually adding modules into our configuration. So we could do @bento/provision S3, and the agent is going to essentially review what we already have inside of our workspace, which of course, as part of the challenge, it already has a few things in there. We don't expect the new users to know everything. So it's contextually finding out what's already there. It's going to figure out what an S3 module is, because it doesn't know that off the bat. It's going to grab information about that, and it'll insert the module, essentially using the same insert button feature, but it does a little bit of added stuff. And then it'll do a full init, plan, and apply, full workflow, which of course we don't want to do in production. That's not ideal. This is just for development, or the dev space. And yeah, so once we get through init and plan, it goes through apply, and it'll present the full plan to the user where we can essentially confirm that we want to apply those changes in the end. And this is, again, just to jumpstart your IaC journey, especially for new developers, but also if you already are familiar with IaC, we don't want to have to write this all up. It's not nearly as fun, so we can kind of have it scaffold a pretty complex solution. So as you can see, we applied successfully and this deployed an S3 bucket to our AWS account, and we didn't know anything about IaC. I guess, well, we know stuff, but some of our new users might not know anything. So it kind of just jump starts, and you can look through what the agent did and what it added, and we can, learn from it. So, cool. All right, so if you've not been paying attention at all up until this point, or you haven't written anything down, this is something that we want you to take away from our presentation. So we develop modules to abstract away pain points within the company. This is kind of a given. It just makes it a whole lot easier in the long run, and we just don't want people repeating the same process. Secondly, we create common module standards, and that's the grading part of this. We want users to be able to determine which modules they like, don't like, and/or which ones are most used. Basically, just means that we want modules that are used in production already, further used in production because they're tested, they're battle tested. Thirdly, we use an IDP, an internal developer portal, to host module catalog. This is for discoverability, and it just makes it finding modules easy, and then also I can send the link to people who ask me questions, which is awesome. Shift discoverability left with the Bento VS Code extension. Now, we're not just shifting discoverability left, we're shifting, or we're kind of giving a leapfrog for their first infrastructure as code. Even if you're a familiar developer with OpenTofu, you can just generate configuration that's governance compliant internally. And of course, this is like a feature already of Copilot. You can write IaC, but the problem with that we had initially is it doesn't generate anything we can actually use. So, cool. Well, let's move over to the last slide, which is just a thank you to everybody attending today. So we want to give you a big thank you, and we want to give a shout out to the OpenTofu maintainers and the organizers as well. So, all right, we'll move over to questions if anybody has anything. You've got a question here.
First off, great presentation. I just wanted to ask, so at Fidelity, for example, can you talk about the teams that would use such a module, and what are their use cases, and how did they go about it?
Yeah. Do you want to go ahead? Or? All right, so the question was what teams use our modules and patterns, basically? Yeah, so essentially everybody internally is using our modules and patterns, unless they just aren't able to find them, which is something we've come across a little bit, is it just teams don't know about it. So we're kind of trying to push our platform out there more, especially recently. But I think a majority of the teams just use them because it makes it easier. So if you want to add a little bit.
Yeah, and I wouldn't say there are modules. We just help kind of maintain the catalog. We have a few we maintain, but there's a lot of teams across Fidelity that build big groups of different modules. So yeah, just want to add that. But yeah, when they implement those security guardrails, though, like it's a lot easier for everyone to use that because their stuff isn't whacked out of like the cloud environment by security controls. So big incentive to use them.
I feel like we had another. Oh, cool.
Hey, great presentation. So one problem I find with Terraform is the module, like the shared module pattern works really well when the resources are coupled to the application, but it becomes harder when you have things that might be shared across a group of applications, like a Kubernetes cluster that you'll put multiple applications on. So you can't just include them in the state for the application because it's bigger than that. So how do you guys at Fidelity manage kind of like the platform-wide configuration, team registration, secret management, SSO group, and that kind of stuff?
I feel like that was maybe a few different questions. Sorry. Do you want to ask one part of that? Like,
yeah, just shared modules for like common across a team or something like that.
So maybe I'll describe more how it, I guess, works within the individual business units. Would that help maybe? Like certain business units have certain requirements that say like, you must use our internal modules because we have more strict rules maybe than the enterprise as a whole. And so that's a pretty common thing. Like some business units say that you must deploy your Kubernetes through OpenTofu, or you said Terraform, but we use OpenTofu. Yeah. So that's one example of that. I'm not sure if that answers your question. I'm sorry.
Like, to give a simpler example, how do you manage AWS accounts that are shared across an entire team?
Okay. That's all the account setup is not done in Tofu. So
Gotcha.
It's not. Or we don't have anything to do with that, rather.
Hey, just a follow-up to maybe the last question, like shared resources like VPCs, right? You're really only going to have, is every team spinning up their own private VPC? Is that?
Yeah, this is you.
There's quite a few resources, like sensitive resources like VPCs, that are still managed by central teams. They may be using Tofu for some of that, but I don't know if they are. And for a lot of it, when they need to spin up a lot of things where you don't want to have that big teralith, I know that there are teams like internal platform teams that do use TerraGrunt for that kind of stuff. I'm not sure if that helps add some context there, but we do definitely have a few platform teams internally that use TerraGrunt over our Tofu offerings, and we make everything work with TerraGrunt just fine. Some teams need that additional tool.
Sure, thank you. Just real quick follow-up. What do you do for testing modules? Like how do they get to graduated? And keeping people up to date on versions? Because I've felt a lot of pain with having to upgrade folks. And yeah, how do you manage that?
Yeah, great question. So with testing, it's part of basically our incubating stages. We require testing through our standard build and release processes, which we can't get too much into. But yeah, we just use Tofu tests though. No, not Terra tests. Some of them apparently. I mean, I think most of them are used like moving over to OpenTofu. I haven't seen a Terra test recently, but and then your second part of your question. Oh goodness, what was it again?
Versioning. How do you keep people moving?
Right. That was something that I commented on like right when I was handed the mic. So it was. Oh man, I could just go back to the slide real quick. Here we are. So it's basically we already deprecate like the OpenTofu older versions of it, so like 1.7, we're already moving towards deprecating that and moving up to like 1.9, 110. So we're just going to kind of use that same process to ensure that modules and providers are up to date. Cool.
All right, we have time for 2 more questions.
Perfect.
Thank you for your talk, guys. Real quick, when it comes to building patterns, how often are your developers straying outside of the pattern, the initial pattern, and making requests to the team to modify, say, resource sizing or something like that? It could be anything. But how often are they coming to you, say, hey, I need a adjustment here, something there?
That's a great question. I mean, can I make a quick? Yeah, just a quick comment on this. We help maintain the patterns, but we also encourage people to contribute to them. So if people are wanting changes to the patterns, they can go ahead and open their own PRs if they so please. And if you want to comment.
Yeah, so you were saying basically how often do people want changes to the larger patterns, not the simpler modules you're asking? Yeah, the more opinionated ones. There are definitely people that, especially when we were developing them, that wanted, there were certain rules that said, like, in certain groups that said we have to centrally provision certain resources and we can't manage them through Tofu or Terraform. And so when we were originally developing them, we had to negotiate a lot of that. So at first it was a lot. It's less now, so with the people that use those patterns. Yeah, and that was just more learning what each business unit required or didn't allow, essentially. But it's becoming less, slowly.
One more question. Glenn?
Thank you. I imagine there are sometimes cases where patterns are very similar. Is there any way to, I guess, find almost not repeat ourselves when creating patterns like that?
So most of the patterns, really, not even most, all of the patterns were kind of created top down.
Okay.
It was more of just we know as an organization, we see these kind of things used a lot for a bunch of different things, and we knew we needed to create some reusable thing that wasn't so low level that it was just really managing like one or a couple similar resources. And so these were like architectures that architects had put together and said, like, these are the kind of things that we know users, dev teams at Fidelity absolutely need. And so we built to those using the building blocks that we had with those smaller common modules.
Just as a follow-up, the example that I have in my head is like using RHEL for production and maybe Rocky Linux for non-production. Is that something that you would want to even embed in a pattern or into one of these nested modules, or is that something that you would make even separate patterns for?
That almost seems like something, though, maybe if it's just a single EC2 instance or VM.
Just as an example.
Yeah. I think for the most part that would be something that would be input to most patterns, unless we knew ahead of time, like, we absolutely can't use Rocky Linux and we could only use RHEL. Then in that case, because I don't know what it is exactly, we would probably just embed that directly and say this is what it's going to use as part of the pattern. And it's not an option, because that pattern could be doing 50 different things, and that could just be a small thing. I think Connor wants to say something.
Yeah, I just wanted to add one quick little thing, because I feel like a major part of your first question was when similar patterns exist, what do we do with them, and how do we kind of, so basically patterns, as we were saying, they're just modules of modules. So basically they use the underlying child modules just a little bit differently if they're that similar. And that's basically it, yeah. Cool, well, I think we're out of time, so thank you guys for being here.